I want to go over how to create a application that will calculate the hex values for a decimal number only. And the purpose of this application isn't just to convert decimal to hex. There's actually a built-in function for that in Python. But the objective is to do an exercise that requires us to handle a for loop, a while loop, some if-else statements, and a list. And so this was a nice, good little assignment that helps us to demonstrate that. So I went ahead and I put a skeleton template here for what I want to do. And there's three functions. The main function, which is where all the other functions will be called and where the data will be returned. And I went ahead and I put a print format in there so that way the output will be formatted and centered. I didn't want for people to have to look up how to use this formatting, so I went ahead and just included it. What it means when you look at the green part right here in the single quotes is that we're going to have eight spaces and then 8 spaces again. It'll hold up to 8 characters on each side. And so the label that's going to be on those two columns is going to be base 10 and base 16. And that is so that when it prints out, this will print out once in this format, and it's going to print out base 10 and base 16, and that way our output's going to be nicely formatted into 2 columns. And so I didn't want people to have to look that up, so I went ahead and just put the code there for it. And I went ahead and wrote the code for the other bases, even though it's not complete, because I want to go through it. So the second function is called base algor, and this is going to be where we place the algorithm that actually does the conversions. And the algorithm that we're going to use is one that is commonly used in computer science textbooks and is well known. So I didn't invent it or anything like that. But we're going to go ahead and use that algorithm, and we're going to modify it a bit for our purposes. It can be used for converting decimal to any base, but we're going to be specifically using it for hex just to satisfy the purposes of this assignment, which again is to practice writing a for loop, a while loop, a list, and some if-else statements. And also just practicing setting up our functions. Okay, so the next one is the Get Hex function. Again, there is a reserved function here that's just called hex that you could just use in Python to return hex. But I want us to do some abstract thinking and to write our own little function that will return the hex value. Down here we see the usual if double underscore name double underscore, and then the rest of it here that's written here. But this little piece of code, remember, this tells the compiler where the entry point into our code is. So it's going to say the entry point is the main function. And so we have our template and we're ready to start. The first thing we're going to need here is I'm going to need a for loop, because the assignment is going to be to convert the first 100 numbers from 0 to 100 from their decimal values to base 16. So to do that, we're going to go ahead and write a for loop. You could write this in a while loop, but right now I think that a for loop is more appropriate, since we actually know what our how far we want to go. So I go through 101, so that way it'll include 100. Technically, we're going through 101 values if you include 0, 0 to 100, and 0 to 100. So we're going to say 101, so that way it includes the decimal value of 100. All right, so the next thing we want to do is include the print statement, and this part here, I'm going to go ahead and write it, even though the rest of the functions haven't been completed. I frequently do this when I'm writing code. I'll go ahead and write it, and I'll just comment it out until I'm ready for it. So here I'm saying print. You'll notice I'm using the same format because I want the outputs to be placed in the exact same format to follow underneath, equally spaced in the 2 columns. And then we use our usual str for conversion of a string. We're going to take I. So as the for loop iterates through 0, 1, 2, etc. to n, we're going to use I as our number that we're going to convert, and so we need to cast that to a string. And the function that we use is str. It's a built-in function, str, system function, and we're gonna cast it to a string, and so that's going to be cast out. And then we're going to call the base algor function, which is right here, and we're going to pass it the values I and 16. So actually, there's no reason I need to comment this, because this algorithm does exist. It's just not complete, and that's right here. So again, our print function with formatting and to 2 columns with 8 characters, and then we're passing it the I itself, parsing it to a string, casting it to a string, and then the calling the base algor function, passing it I, the value I, and then passing it 16, so it'll be converted to base 16. All right, that's really about it for this for the main function. There's not a lot going on there. So this is how I like to set mine up, nice and clean. Now we need to work inside the base algor function. So we'll go ahead and do that. And we have our what I'm going to call the BS string, and that just stands for bit string. We could name it whatever we want to. We could name it the hex string or something. I don't know. Okay, so the next thing we need to do is we need to create an if statement, and then we're just going to say if the value for a decimal is 0, so we can handle that. So let's go ahead and do that. So if the decimal, actually that's wrong, 0, then we want to say bstring equal, and we're going to just cast it to a string, and that's done. Okay. Of course, we need our else statement, so let's go ahead and do that. And in the else statement, let's go ahead and make sure our formatting's right. In our else statement, we're going to go ahead and use the while loop. And this is so we can iterate through, this is where we're going to place our algorithm. So this is the function where the algorithm will be handled to convert from decimal to actually any base, but we're going to be using for base 16. So I'm going to go ahead and write this up, and then I'll go ahead and explain it. So I completed the while loop, and what I'm doing here, just to explain the algorithm, is the decimal value will come in, and we're making sure that it's greater than 0. So the while loop will stop when decimal value hits 0. Okay, so as long as it's greater than 0, this is going to iterate through. So iteration comes in, and we're going to look at the modulus of decimal to base. So let's say decimal is 10, and the base is 16. It's going to divide 10 by 16, and then whatever's on the right side of the decimal place is going to be returned, and that's called modulus. So the modulus of 10 and 16 is basically the division, but only returning the remainder. And so that's what's happening here. Next is the decimal value. The decimal will be adjusted. So decimal is going to now be equal to decimal, and this right here means that we're going to take the quotient of the decimal divided by the base. So we're going to take that value, and then decimal is going to change. And so what's going to happen here as this iterates through is decimal is going to keep getting smaller until eventually it hits 0, and then the iterations will stop. Now this little piece here, I'm going to go ahead and leave this in. It doesn't need to be here. We basically, because since we're working with just base 16, we could just have just this line of code right here, and nothing else would be necessary. But I'm going to go ahead and leave this in because I like this little function that I can use for converting decimal to pretty much any base. So we're going to go ahead and leave it in for our purposes. Like I said, we don't even need this chunk of code right here. It could be deleted, and this would work fine. But I'm going to leave it in because, like I said, I like it being able to handle any base. So if not base 16, then this is what would happen. The B string would be equal to the remainder plus the bit string at the end, and as it iterates through. However, since this is going to be base 16, the else statement is always going to be what's hitting. B string is always going to equal the get hex function with the remainder plus the bit string. So the get hex function is going to take the remainder, and it's going to pass the argument remainder to the get hex function, which is down here, but nothing is going on yet. So this is this function right here is now functional and working, and we can now get down to the Get Hex function. And we're going to have a little bit of fun with that one. Again, remember this is could be done in the could be done as a reserved keyword, but what we're going to do is we're going to change it a little bit here, and I'll show you what we're doing. Okay, so what I did is I said, let's take the hex, we're going to create a list, which I'm going to call the hex list, and we're going to take the values A, B, C, D, E, and F, because hex, counting to hex is, are the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it becomes A, B, C, D, E, and F for base 16, and that's what hex is. So rather than put the numbers here, and I could very easily enter the numbers 0 through 9 in this same array, and it would be really simple and easy. But because I'm a bit of a nerd, I want to have fun with it and do a little bit more work with it. So we're going to do some other things. So we're going to say, okay, if h, so the value that's been passed, the argument that's been passed, h, is less than 10, then we're going to say h out is equal to h. And so what does that mean? That means that nothing's going to happen as long as it's a number. So 0 through 9 come through, they're going to be returned as 0 through 9. Okay, because nothing changes from 0 to 9 in hex. However, if it's 10 or greater, then something does change. We need to capture one of those letters, and we're gonna get those from the list up above. But the first thing I need to do is I need to do this little thing here, which is just kind of a cool little thing that I did. And I'm going to say h is going to be equal to h minus 10. And that's because the index for the array is 0, 1, 2, 3, 4, and 5. So what I need to do is say, what if the number 10 gets passed? So the argument 10 gets passed. 10 is, h will be, 10 is obviously not less than 10. So it's going to fall to the else. So therefore 10 minus 10 would equal 0. What is the index for the index in the hex list for 0? It's A. If 11 was to come through, well, 11 minus 10 would be 1, so we'd have B. 12 would be 2, and so we would return C. And that's how we would get these numbers. Again, this would be much easier if I was just to enter the numbers in here, but I like the way that I'm doing it, so we're gonna stick with this way. Okay, so this is just gonna say h out equals, and this is gonna be the hex list, and we need the index value, and that's gonna be h, and then that's it. So now this is complete. It's done, just like that. Really quick, simple, and easy. So I'll scroll through it. Again, the main function with the formatting and calling the base algor function right here, passing it the value I, so that way we've auto-generated the numbers 0 through 100, and letting the algorithm know that it's going to be base 16. Here in the algorithm method, we pass the decimal value and the base 16. This happens, it does the modulus and then the quotient, and then does the concatenation with the string, and there we have it. So we'll test it here. So I ran the code, and there were 2 errors, and I want to point those out. So if you were following the code line by line, the first error was I forgot the colon right here in the for loop. So if you were following the code prior to what you're seeing on your screen, you needed to add this colon here. All of your for loops and your while loops and if statements need this colon. And sometimes I forget to put it in there. So I had forgotten that. Another mistake here was I had written if decimal equals 0, and that's not what I wanted to say. We want to use the comparator, so we want to say the double equal sign, which means if the decimal, and really the way to say this is not equal, but is the same as 0. Because we're not saying that we're going to set it to 0. If, for example, the equal sign says B string is equal to string 0, which really is saying the memory value B string, it will be assigned what the variable value of 0 cast to string. Here we're saying if this value in memory is the same as this value, then let's let this happen. So that's really what the comparator here is saying. So there was 2 mistakes in the code prior to this view, and that's the colon and the second equal sign. Other than that, the code works. We'll go ahead and run it and see what happens. and it calculated very quickly. It's a pretty efficient piece of code. So as you can see, this is base 10, this is base 16. I want you to note the formatting. This is centered under the base 10. This is centered under base 16, and that's all due to the formatting right here and also right here. And those two things are what line up our output so that it's nice and neat. And if you look at our code, for example, 15 is F, 16 becomes 10, and so forth. I always look at 47 because that's always a good one. 47 shows us 2F, which is correct. And so there you have it. You have our algorithm. I'll put this to the side. Base 10 to base 16. The numbers are 0 through 100, calculated correctly, and in base 10 and base 16, or hex. I think that's all we need to do. Could this be simpler? Yes. I could eliminate this whole block of code right here. What's highlighted could be gone, and all of this could be gone, and the only thing that would be necessary is for this one array and for it to have the numbers 0 through 9 added before the A, and this would work well, pretty much the same. But like I said, I like this solution. I'm a little bit of a nerd, so I like having my own little algorithm. And that is it. I hope you enjoyed it.